Hey folks, here's a review for the quiz on 21 and 22. First thing we're going to do here is graph these things, state the domain, range, and asymptote, increasing, decreasing. So this one, if I had a parent graph for this, it would just be 4 to the x. You always look for the thing that's being raised to the exponent. So this one would be shifted down 5 and vertically stretched by 8. So when I look at my end graph, I'll know it's good if it's if it's been moved down 5 and all that stuff. So let's check it out. And I typed in my graphing calculator. That's what it looks like. I'm going to get some points to graph by looking at my table. So it looks like I have 0, 3. I have 1, -3. Sorry, -1, -3. And 1 is up at 27, so that's super high. That's where it goes like crazy high. And then I have -2, -4.5. So down here, and then it gets closer and closer to 5. By the time you're at -3, you're closer. -4 is like 4.9, -4.9. So it's super slow at first, like all exponentials, and then all of a sudden it goes way up. Okay. So that's an exponential growth, and the domain is always -infinity to infinity. The range of the y values, the lowest this goes is -5, and since it doesn't get there, I put a parenthesis, and then it goes up forever. Y-intercept is where it hits the y-axis. That would be 0, 3. And the asymptote is the line it approaches but doesn't cross, and that's this y equals, oops, that's a -5 there. Y equals -5. Okay. Is it increasing or decreasing? If I were writing this from left to right, it goes up the whole time, so that would be increasing the entire time. All right, let's get that next one. All right, so the next one behaves like y equals e to the x. Let me make this a little brighter. Boom, boom. Okay. So the parent is that, which is our things that grow continuously. And, this is another exponential growth. If you looked at the graph, it's pretty slow early on, and then it takes off, just like exponentials do. For some good points, you'll see at like -5, it's just barely above 1. And it kind of stays like that, and then eventually, even at 0, it's pretty much at 1. And at 3, we're finally up at like 1.3, so it's barely starting to move up. It's just hovering just above 1. And then all of a sudden at 4, it goes up to 2. At 5, it goes up to 3.7. And then at 6, we finally start to see that thing take off, and it goes 8.3. So that's off screen. So it's super slow at first. And all of a sudden it goes crazy high. All right. Another exponential growth that's increasing the whole time. It's going up. The y-intercept for this guy is going to be at 1.01. So you can get that by plugging the 0 for x here. 1.02, I guess. Domain is all real numbers. Range is the lowest y of 1 to the highest y of infinity. And the asymptote is here at 1, so you write y equals 1. All right, so graphing's not that hard. You just need some dots and shift and flip. One thing that's not on here that will be on the quiz is, well, oh, there it is. Describe the transformations. Never mind, it's right there. All right, you will get the formulas just like here. We got growth, decay, compound interest, and continuously compounded. So what's the decay factor? The decay factor, this first one, is the difference between that number and 1. So if it's under 1, you have to do this. And you would say it's actually a 20% decay. Sorry, that's the decay rate. I answered the wrong question. The decay factor is 0.8. That was my bad. If they ask for decay rate, you'd say 20%. If they ask for decay factor, you actually give the number that's being raised to the x. What's the percentage growth of this guy? So here, you look inside here at the growth factor, and you take away 1, just like we did up above. We took it away from 1, and you get 0.25, which goes to 25% growth rate. Okay, so there's that one. Answer the following questions. So here you just got to pick the right formula. Since I read through here and I see this phrase here, this is important. When I see compounded monthly, I know I'm going to use the compound interest. The only time I don't, and I see the word compounded, is if it says continuously. So I'm going to use this. So I'm going to use the A equals P times 1 plus R over N to the NT. I just got to plug my numbers in. The principal is the starting amount, which is 2500. The rate is 6.5 annual percent, so 0.065. Don't mess that up. Monthly means your N equals 12. So in both places, here and up here, I'm going to write a 12. And how long is it going? 5 years. Make sure you put that in parentheses. You can type that all in at once and get your answer. And if I do that, type it all in correctly, you get 3457.04. Since this is money, that's a good place to round it and put our dollars on there. So that's how much it grows to in 5 years. Now find the balance in the same circumstances except it's compounded continuously. So that means I have the same amount of time. The only difference is I'm using this formula. It says continuously. So PERT is what we're going to use, and we're going to say, okay, my starting amount's still 2,500. My E is just a number. My rate's still 0.065, and my time's still 5 years. So we'll go ahead and type that one. And if you type that in, you get a slightly bigger number. That's 3460.08 if I round it to the nearest cent. So you make a couple bucks more if it's compounded continuously. All right, couple more. This has a key word here. Depreciates means goes down. So that would be one of these exponential decay functions. So I want to make sure it goes down 8% annually. So I'm going to be using y equals amount times 1 minus r to the t. See how it didn't say compounded monthly or anything like that. So in this problem, I'm going to go, okay, your car started out worth $7,000. And I'm going to take away 8% annually, so make sure you do 0.08. Don't do 0.8 or it'll be 80% annually. And I want to know the exponential decay model is this. Oh, I guess they said V. Let me change that to a V. Hold on. There we go. The value is 7,000 times 1 minus 0.08t. And then what's the value of your car after 4 years? You just put a 4 in there. You could put a 0.92 because that's what it is. And if you type this in your calculator, you get $5,014.75 for what your car is worth after 4 years. Only going down 8% a year, which is actually, not bad. Most cars go down by more. Maybe it's a Jeep. All right, now we get to the describe the transformations parts. This is where you're going to say if it's shifted or it's flipped or all that. So if this is the parent, how is this different? Well, there's a lot of things different to it. First, the 1/2 would be a vertical compression by 1/2. The +1 up here is a shift left 1 because it does the opposite of what it looks like. The -4 back here is a shift down 4. That one doesn't lie to you. All right, and if I wanted to graph it, I could. It would have all 3 of those moves in it. All right, now we're going to go switching from log form to exponential. So remember, you kind of do the swoop. So you're going to say, okay, it was this. I'm going to take the base to the exponent equals the answer. Same deal here. We'll swoop in 8 to the exponent, which is over there, equals 512. And we're swooping here. 5 to the negative 2 is 1 over 25, which is all those. So you're doing the swoop every time. Now you got to do it backwards on the next three problems. Here, it's in exponential form, and I got to write it in log form. So normally I steal the base. I would write like log base 10. And then I put my exponent on the other side. Think about the swoop where the exponent starts out. And then the 100 goes in here. Now there is one problem with this. It is math tacky to write this because that is actually one of the two special ones we have called common log. And you should be able to just write it as common log of 100 equals 2. That's one you can type in your calculator. Same deal here. I have another base 10. We'll get rid of that in a second. I put my exponent over here. Make sure the x is on that side and the y is inside. And then really that's common log of y equals x. There are only two of those. Okay. Evaluate. This would be without a calculator because you have to know that the base here is 10. And it says, a log asks the question, 10 to what power would equal 10 to the 5th? Well, that's pretty easy, of 5. If you ever get stuck on these, you can always set it equal to x and do the swoop thing. And you'd easily see that that must be a 5. Here's another one. You're saying 10 to what power equals 1 over 10,000. So normally I count the zeros, 1, 2, 3, 5. So my answer would be 5, but it's 1 over, so I have to remember to put a negative 5. Same deal here. 5 to what power is 125? Well, 5 to the third, so your answer is just 3. Notice my answer is not 5 to the third. Logs ask what exponent goes on a 5 to make 125. All right, last chunk, we're going to expand and condense. So we're going to start off condensing. So we use our 3 rules from the other day. One of the rules is if you see a number in front, you take it up to the exponent. So common log of 3 squared plus common log of 1/9. And then another rule is if I see a plus between two logs, I can combine them into a single log and I multiply what's inside. So you're going to take 9 times 1/9, which is also known as common log of 1. Now this one says don't just do a single logarithm, but also evaluate. So I should be able to find the answer to this one. 10 to what power is 1? And 10 to any power is 0. Okay, now on to this one. I'm going to use my rules here. So common log of 80 minus common log of 2 to the third, which I'll call 8. And if I have minus, I need to do subtraction. That was another rule of ours. Do division. So really, this is common log of 10. So 10 to what power equals 10? And 10 to the first power. So 1 is your answer. And my last two problems, I'm going to expand these out. So when I see multiplication inside a log, I'm going to rewrite it with addition between two logs. And then I bring this guy out front, and you'll have 2 common log of x plus common log of y. Similarly, over here, if I see multiplication or any number on top gets a positive, so I'm going to have common log of x plus common log of y, and then minus common log of z. Because any number on the bottom is a negative exponent, so the z gets the minus sign. The two others are positive. You don't have to write a plus in front of it. That's just silly. I didn't have to deal with any exponents on that one, so hopefully that made sense, and you can do some studying, look that stuff over, look over your notes and homeworks and stuff like that. And yeah, prepare for this quiz tomorrow. Talk to you later.